All right, so yesterday, okay, so tonight is due these problems, section 1.6, as is the web assignment. Um, I do owe you a couple of back homework assignments. I'll get those to you today, hopefully. Um, and here's the other current assignments. Next 1.7 and 1.8, starting next week. Um, uh, yeah, make sure everybody, submit PDF files only. Please stop submitting JPEG files and submit it as one PDF file. Okay, not multiple PDF files, not JPEGs. Okay. Or GIF or whatever else, files, etc. Again, Adobe Scan and Cam Scanner are great applications on your phone for doing this. They're freely available and they're easy to use. It's a lot of grading for me, and when I'm, spending time, flipping around pictures in multiple files, it becomes more difficult. So as a courtesy, as adults together, as courtesy to each other, submit one PDF file. What else? That's all I wanted to say about that. So yesterday, we were on section 1.7. We went over sections 1.7 and part of 1.8. So let's do some problems in section 1.7. Oh, now I remember what I wanted to say. The second exam, exam 2, will cover sections. So it's 1.6 to 1.7 and 2.1 through 2.8. So we're starting on 2.1 today. So we're still probably about 2 weeks off from having the second exam, but this is what we're aiming for. Okay. So that's the next third of the material of the course, essentially. So let's take a look at some problems in section 1.7. So we were assigned in 1.7 15 to 63 every sixth problem. So 15 to 63 every sixth problem. So 15, 21. So let's look at 21. So section 1.7, 21. 1/2 x, so solve for x. 1/2 x minus 2/3 bigger than 2. Okay, so linear inequality. Linear inequality is solved much like a linear equation. Right, you can add something to both sides and it preserves the inequality. So 1/2 is bigger than 2/3 plus 2. That's 8/3, right? 6/3 plus 2/3. And then we can multiply both sides of the equation or the inequality, by a constant, and it preserves the inequality when what you're multiplying by is positive. It reverses the inequality when what you're multiplying by is negative, right? So here the 2 is positive, so the inequality is preserved. So x is bigger than 16/3. So that's your answer in terms of inequalities right here, just a simple inequality. X bigger than 16 thirds. So on a number line, here's 16 thirds, a little bit bigger than 5. And we're looking for all the numbers bigger than that, and because we're not including 16 thirds itself, we use the open circle rather than a closed circle. Well, open circle rather than a solid dot. And in interval notation, that's 16 thirds, 16 thirds to plus infinity. By the way, a note about writing mathematics again. It is perfectly acceptable in most situations to write your fraction like slanted like that, or horizontally like that, or something like that. For simple fractions, in most instances, just a number over a number. However, in many instances, like when you're working with rational functions, I mean like x plus 3 over x plus 1 times x squared minus 5, or whatever, these sorts of things. In these cases, it is definitely not acceptable to write it slanted, like, I mean, however you might do it. So this is usually acceptable for just numbers, but it's never acceptable for rational functions. This is completely unclear. It's not acceptable in the sense that you can't make sense of it yourself when you're working with it. It needs to be written vertically. Okay, so if you always write it vertically, then, all the better. I almost always write it vertically except when I'm trying to squeeze it in or something like that. So just a note about writing fractions. Actually, among you guys, I haven't seen anyone really sort of write them in a slanted fashion, which is sort of surprising. All right, so that's 21. Other problem, 27. 27 is one of these three-way. So solve for x. So minus 6 is less than or equal to 3x minus 7 is less than or equal to 8. So this is two inequalities at the same time. Minus 6 is less than or equal to 3x minus 7. And 3x minus 7 less than or equal to 8. Right? So that's two simultaneous linear inequalities, which is fine. You can work with that and solve them together at the same time. You can do that, you can combine them because these inequalities both include the 3x plus 7, and they both point the same way. They point to the left in this instance. They could point to the right too, is fine. Other types of inequalities you can't combine like that in one line. But these kinds you can. The answer in these situations comes out to be an interval. Now, when you're solving, make sure there's three expressions that you're comparing. So what you do to the one expression, you got to do to all three. Well, what value you change the one expression by, you add to each expression, you got to add to the other, to all three. So this is 1 less than or equal to 3x less than or equal to 15. Right? And now I'm going to divide by 3 in each expression, and because 3 is positive, we don't have to flip the 5. We don't have to flip around the inequalities. If it was a negative 3 and you divide, then you have to flip. So we're going from 1/3, and we're including the 1/3 to 5. All right, so in interval notation, 1/3 to 5, including the 1/3 and including the 5. Let's get one more linear with the negative. Yeah, here we are, 32. Oh, wait, which one am I asking you to hand in? 30 I asked you to hand in. Yeah. Let's do 32. So among the ones that are assigned, I'm just not seeing anything that's got a negative coefficient in there. So I'll just do 32 as an example. So solve for x. Negative 1/2 less than or equal to 4 minus 3x over 5 less than or equal to 1/4. So among all these fractions here, okay, the denominators have 2, 5, and 4. So a common denominator would be what? Least common denominator for all these fractions would be what? Among 1/2, 5, and 4. The least common multiple of all those numbers.
20.
20, sure. So I'm going to multiply each part of this by 20. All right, 20 is positive. All right, so I don't have to reverse the inequalities, although I will later. So 20, here we get minus 10 is less than or equal to 4 times 4 minus 3x is less than or equal to 20 over 4 is 5. Okay, so let me distribute this. All right, I'm going to subtract 16 from each part of these inequalities. So we have minus 26 is less than or equal to minus 12x is less than or equal to 5 minus 16 is negative 11. Right? Now I'm going to divide by negative 12. So because I'm dividing by negative 12, the inequalities get flipped. Right? So we have 26 over 12, so that's what, 13 over 6 is bigger than or equal to x is bigger than or equal to 11 over 12. So the answer is, as inequalities, that. So we have 11 twelfths. So notice they're all pointing to the right now, so the order, you can turn the whole thing around if you want. Put the 11 twelfths over here and the 13 sixths over there, but no need. So that's 11 to 26 twelfths. And it's that interval there. Okay. So something to remember with those inequalities.
I have a question.
Sure.
So, how can you put 26 twelves? Can you put 13 6 on the number line, or?
Oh, wait, where did I get 13? Oh, 13 6 is 26 over 12, just as a manner of comparison.
Oh, it doesn't matter.
With 11 twelfths, you know what I mean?
Yeah.
Yeah. You can.
Okay.
Right. So,
all right. Thank you.
Yeah, yep. You compare them over the same denominator that way.
All right. Thank you.
Mm-hmm. So 33, stuff like that. 39. Let's take a look at 39. So 39 is a quadratic inequality. So 2x squared plus x bigger than or equal to 1. So polynomial inequality of degree 2. Quadratic inequality. I just can't stand that word quadratic. I mean, it's like it's degree 2, yet quad means 4. Quad sort of, bringing to mind squares, because a square is, geometrically a square or whatever. So, but I don't like it. But we're stuck with it. It's tradition. What are you going to do? So you need to, with a polynomial or rational function inequality, is to make it 0 on one side. Okay, so 2x squared plus x minus 1 bigger than or equal to 0. And then factor fully. Okay, so this factors as a little bigger. I mean, if it factors, it's got to factor like this. Right, if it factors with integers, it's got to factor like this, because the 2x squared is only going to be 2x times x, and the negative 1 is going to be 1 times 1. So the only issue is where the plus and the minus goes. Well, it's here. That works, right? Because this is minus x plus 2x. Minus x plus 2x is plus x. All right, so now, where does this polynomial expression equal 0? Where does it equal 0?
One half and negative 1.
Now, x equal to negative 1 and x equal to 1/2, the solution to that one equal to 0. So this equals 0 at these two numbers. So you take a number line and you put those numbers there. So negative 1 and 1/2. Now, are those part of the solution or not? So this polynomial expression equals 0 at those 2 points. And since we're looking for bigger than or equal to 0, those are actually part of the solution. Okay, now you've got these intervals defined. So you pick a point, any point in these intervals, the easiest one to work with, and you test to see whether this is positive or negative. Okay, with polynomials and rational functions, the only time you can switch from being positive to negative is where the expression is 0 or the rational functions wherever you're dividing by 0. That's the only time you can switch. Okay, the reason for that is, a little bit more complicated than, than what you would be led to believe. It's actually fairly complicated, the reason for that. Although, I love how textbooks never really kind of say that. They're just like, well, it's obviously true, and I'm always kind of like, well, no, it's not. But anyway, it's different. So pick a number in here, negative 2. Okay, x equal to negative 2. And we're not interested in what it actually equals, this expression. Just, is it positive or negative? So I stick negative 2 in here. I get negative 4 minus 1. It's negative 5, but I'm not interested in the fact that it's actually negative 5, just that it's negative. Stick negative 2 in here, that's negative. Well, negative times negative is positive, and we're looking for, 0 or bigger than 0. Bigger than 0 is positive, so that interval is part of the solution. Pick a number in here, 0. Plug 0 into here, you get negative 1. Plug 0 into here, you get positive 1. So it's negative times positive, which is negative. But we don't want negative, we want positive. So this is not part of the solution. Pick a number in here, 1. Plug the 1 in, 2 minus 1 is positive. 1 plus 1 is positive. Positive times positive is positive. So that is part of the solution. So this is the solution to the inequality 2x squared plus x bigger than or equal to 1. Okay, it is the intervals where x is less than or equal to negative 1, or x is bigger than or equal to 1/2. This type of interval, you can't line up the inequalities, because it would look like this: minus 1x x bigger than 1/2. Right, so this is saying that minus 1 is bigger than 1/2, which it isn't. Right, so you can't really line up the inequalities together. It's only when you have just a single interval that you can line up the inequalities. So these are the way it looks as inequalities. This is the number line. If you want to write intervals, it's minus infinity to negative 1. And then we use this u, which means union, 1/2 to plus infinity. The best way to sort of visualize the solution, I think, is on a number line with these multiple interval type answers. 42, similar to that. No, 42 is the one I asked you to turn in, right? Yeah. 42. So that's similar to number 42, what we just did. So let's take some rational function type inequalities. 57. Oh, how about 51? 51 is nice. Let's take a quick look at that. So 51, it's already factored for you and set equal to 0 on one side. So x minus 2 squared, x minus 3, x plus 1 less than or equal to 0. Right? So this expression equals 0 at what points? Where is this expression equal to 0? Well, at 2.
2, 3, and negative 1.
Yeah. So, and those are going to be part of the solution because we're looking for less than or equal to 0. So now you've got these intervals, so we test them. So take a number in here, x equal to minus 2. Well, minus 2 is negative, but we're squaring it, so that square is always going to be positive. Right? It's a negative squared, it's positive. Or if it's a positive squared, it's still positive. Okay, so this has no effect really. And then the x minus 3, well, that's negative. And then minus 2 plus 1, that's negative as well. So the whole thing is positive. So this interval is not part of the solution because we're looking for where the expression is 0 or negative. Okay, between negative 1 and 2, pick a number, 0. Well, 0 minus 2 squared, whatever 0 minus 2 is, when you square it, it's positive. 0 minus 3, that's negative. And then 0 plus 1, that's positive. So the whole thing is negative. So this interval is part of the solution. Between 2 and 3, 2.5, right? So the squared bit is positive. 2.5 minus 3, that's negative. And then 2.5 plus 1, that's positive. So it's still negative inside here. And then larger than 3, well, all of those are positive. So that's not part of the solution. So in this here, the solution is just minus 1 less than or equal to x less than or equal to 3. So it's just the interval from minus 1 to 3, including the 2. So the 2 actually had no effect on it because that's where this expression x minus 2 changes from positive to negative. But it didn't matter because we're squaring it. So it doesn't switch the product from being positive to negative at any point. All right, so now let's do 57. So we got a rational function 4x over 2x plus 3 and bigger than or equal or strictly bigger than 2. Okay, again, it's got to be 0 on one side. Okay, so you got to move everything over to the left or the right, however you would prefer. And then you have to add the rational functions together so that you have one rational function and then factor fully. Okay, so this 2 is equal to right? 2 times 2x plus 3 over 2x plus 3. Get that common denominator so I can add these guys. So this is 4x minus 4x minus, well, let me do an extra step. Minus, so this is 4x plus 6 over 2x plus 3, like that. So now I'm going to subtract. So what mistake must I guard against is this. You're subtracting the numerator, this numerator from that. You're subtracting this numerator from this numerator. But when I say I'm subtracting this numerator, I got to subtract the whole thing. So if you got multiple terms, you got to put that expression in parentheses. Otherwise, you're not subtracting the whole thing, but just the first bit of that numerator. Okay, so this is minus 6 over 2x plus 3. And that's fully factored. Right, so the numerator is never 0, so the denominator is 0 when 2x plus 3 equals 0. So that's x equal to minus 3/2. So the only like so-called critical point that I've got is negative 3/2. Now, when you're talking about the denominator being 0, that's never part of your solution because the function, the rational function, is just not defined there. Right? You can't divide by 0, so you would never put a solid dot where the denominator is 0 because that can never be part of your solution. All it can do is be a boundary to help define your solution. Even if it said this, like even if it was bigger than or equal to 0, when the bottom is 0, the function isn't defined at all. Right? Again, you can't divide by 0. It doesn't make sense from a whole, variety of perspectives. All right, so we just have two intervals to test here. So that's 1.5. So let's take x equal to negative 2. So the numerator, negative 6, is negative. The denominator, negative 4 plus 3, that's negative. Negative over negative is positive, just like multiplication. Right? So that's part of your solution. And then over here, x equals 0. The numerator is negative, the denominator is 3, it's positive, so that's negative, so that's not part of your solution. So there's the answer in graphic form on the number line. So it's just the interval from minus infinity to minus 3/2, not including the 3/2. So x strictly less than negative 3/2. One more rational function. So I asked you to turn in 1634. No, that's the wrong section. 40, 30, 42, and 66. 30, 42, and 66. All right, so 66. So something like 66 would be 63. So a little bit more complicated with the rational functions. 1 plus 2 over x plus 1 less than or equal to 2 over x. move everything over to the left. So we have a 0 on the right. All right, least common denominator, right, is going to be x times x plus 1. So we have to get all of these as a fraction over x times x plus 1. Well, the 1's easy. This one, 2x over x times x plus 1. And this one, 2 times x plus 1 over x times x plus 1. Less than or equal to 0. Add all those together. So I have x times x plus 1 plus 2x minus 2 times x plus 1 over x times x plus 1. Alright, so now we need to simplify this expression as much as, simplify and then factor as much as we can. Okay, so first we have to multiply through, get it into standard form as a sum of monomials, cancel out, common, terms that we can, collect like powers of x, and then factor. So we gotta go through that whole process. So x squared plus 2x minus 2x minus 2 over x times x plus 1, less than or equal to 0. So I have x squared. So x plus 2x minus 2x, that's just plus x, minus 2 over x times x plus 1. This factors as x minus x plus 2, x minus 1 over x times x plus 1 less than or equal to 0. Okay. Fully factored, one rational function, fully factored on the top and on the bottom. So numerator is 0. Numerator equals 0 at x equal to 1 and minus 2. Denominator equals 0 at x equal to 0 and minus 1. So we're going to put all those numbers on the number line. But because it's a rational function, there is going to be a difference between where the numerators are 0 and the denominators are 0. So we're looking for less than or equal to 0. Less than or equal to 0. When the numerator is 0 and the denominator is not, right, so like 0 over 5. So let's divide nothing into 5 equal parts. Well, that's 5 equal parts of nothing, right? So the numerator being 0 and the denominator not being 0, the fraction equals 0. So that would be equal to 0. So those are fine where the numerator is 0. That's going to be part of the solution. So at 1 and negative 2. But where the denominator is 0 and it doesn't matter what the numerator is, where the denominator is 0, the fraction is simply undefined, and those will be boundaries for the solution, but won't be solutions themselves. So I need some extra space here. So at 0 or negative 1 first, and then at 0 and then positive 1. Okay, so the negative 1 is not part of the solution. The 0 is not part of the solution. The negative 2 is, the 1 is. Okay, so now you got these 4 intervals and you test them. So let's take x equal to minus 3. So at minus 3, it's negative, 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 negative. So negative times negative over negative times negative. So that's a product of 4 negatives. So that's positive. So that's not part of the solution. And then, just to save a little bit of time, because there's no squares in here, it alternates. So that's what the answer is going to be. Okay. But, if you don't see it that way, so negative 1.5, so x equal to negative 1.5, This is positive, negative, negative, negative. Product is the three negatives is a negative. Between here, x equal to negative a half. So that's going to be positive, positive. So positive, negative, positive, negative, or negative, positive, positive, negative, negative, positive. So that's going to be positive, the product, so on and so forth. Okay, it's going to be like that. There's no squares, so it alternates, essentially. Because each time you cross one of these boundary points, you flip one of the factors from positive to negative. And because you're not squaring it, there's not this phenomenon of non-flipping. So it's negative 2 less than or equal to x, strictly less than negative 1, or 0 strictly less than x, less than or equal to positive 1. So in interval notation, negative 2 to negative 1, union 0 to 1. So those are your answers, this number line and these. So similar to 66. 66 will be a lot like that. Okay? Last thing in 1.7, we have not yet this semester really done any word problems or story problems or like verbal problems. I don't know how you feel about them. Like sometimes, like folks are a little more comfortable just dealing with algebra. For 99.9% of the people in the world, algebra in and of itself is not that interesting. But using algebra to make sense of, like, not necessarily, a real world example, but, verbal information, using mathematics to deal with verbal information, that's the important skill. So, it's nice to be in that category, right? So, thinking about these, word problems or story problems is definitely a good way to go. So the one that's assigned in the syllabus was 79 and 82. So 82. So a telephone company has two long-distance plans. So this was written 25 years ago. Even 30 some years ago. So a long-distance telephone company has two long-distance plans. Plan A is $25 a month and 5 cents a minute. So $25 a month plus 25 cents a minute. And Plan B is $5 a month and 12 cents a minute. For what range for how many minutes of long distance calls would Plan B be advantageous?
I think Plan A is 5 cents a minute.
Oh, 5 cents a minute. All right. For how many minutes of talking would Plan B be cheaper? Right. Obviously, like Plan B, if you only talk like a minute or two a month, on long distance, then Plan B would obviously be cheaper. But how far does it go before Plan B becomes more expensive than Plan A? Okay, well, the cost, you know, so let X equal the number of minutes of, you know, talk time. Right, so the cost of plan A, right, is, well, it's $25 plus 5 cents a minute. So 5 cents is $0.05 times X. Right, so I talk X minutes at 5 cents a minute. That's multiplication. So $25 plus, you know, $0.05 times X. Right, and the whole thing is in dollars. So when you're adding together numbers that have labels, right, you got to make sure you're adding the same labels. Like I can't do like this, for example, $25 plus 5 cents. Right, so you can't add, well, I mean, you can add dollars and cents, of course, but you have to do this transformation, right? 5 cents is $0.05. So $25 plus 5 cents is not 30 something, right? $25 plus 5 cents is 25.05. So you always have to add, you know, things with the same labeled quantity, right? Like 1 teaspoon plus 2 teaspoons is 3 teaspoons. 1 teaspoon plus 2 tablespoons is not 3 of anything, right? You have to do the conversion between the different units that you're talking about. The cost for Plan B is similar, 5 plus 0.12x dollars. $5 a month plus 12 cents a minute. So when is Plan B cheaper? So you're looking for the cost of Plan B to be less than or equal to, well, cheaper, strictly less than 25 plus 0.05x. All right, so it's just a linear inequality. We can subtract 0.05x from each side. So I have and subtract 5 from each side. So I have 0.07x less than 20. So now I can divide by 0.07. Right, so 20 divided by 0.07. Yeah, by the way, Google's got a built-in calculator, so you just go to the, whatever web browser you use, Firefox or Google or whatever, just put it up in the search bar or the address bar or whatever this thing is called, and it'll do the calculation for you. For simple things like that, if you want to go to Wolfram Alpha for more complex calculations, you can do that too. There's a lot of really nice resources online for doing calculations. And then if you're really a glutton for punishment, you can use Sage, which is this free mathematical software package. But anyway, so 285.71, so you can round it off. So X is less than 285.71. What's the units here? What was X?
Minutes.
Minutes, right? Right. So Plan B is cheaper up to 285 point. Which is what, like 4 hours and 40 minutes, right? So Plan B is cheaper up to 285.71 minutes. So it's a nice little calculation. All right. Let's finish up our discussion on section 1.8. So we were talking about inequalities with absolute equalities, equations and inequalities with absolute value expressions, and we went through these types of examples first. So solve for x when like absolute value 3x plus 10 is 25. Well, you have to eliminate the absolute value symbol. So when you say absolute value of something is 25, something is 25, or that something is negative 25. All right, so we did a little bit of that when we were solving quadratics with completing the square, quadratic equations by completing the square. All right, so now we're just being a little bit more formal about it. So whenever you have absolute A is equal to B and B is bigger than or equal to 0, that means A is B or A is negative B. So we use this to eliminate the absolute value symbol. A couple other things to remember about absolute values. They distribute over multiplication and division, but not addition. Okay, so please don't. I mean, probably most of you who are listening to me are not making this mistake. It's those of you who aren't listening to me, so I'm sort of talking to the wind, I guess. But, you know, they're not the same thing. So now when you're doing, so absolute values are perhaps a little bit more more often used with inequalities than with equalities. But some rules for working with absolute values and inequalities are here. So absolute value A less than B means that A is between positive B and negative B, strictly between. So this interval for A. Less than or equal to absolute A less than or equal to B means you're in here with including the B and the negative B. Absolute value of A bigger than B or absolute value of A bigger than or equal to B means that you're outside of that middle interval here, right? So like if B was 6, so here's 6 and here's negative 6. So if you're saying the absolute value of A is bigger than 6, that means you're like 7, 8, 9, 10 positively, or negative 7, negative 8, negative 9, negative 10. So on a left to right basis on the number line, you're either to the left of negative B or to the right of B. So, some examples in my notes here. So, example. So, solve for x. So 4x plus 1/3 absolute value less than 5/3, like this. Okay. So in order to solve the inequality for x, you need to, again, eliminate the absolute value. And what this means is that this expression 4x plus 1/3 is less than 5/3 and is bigger than negative 5/3. Okay, so in terms of inequalities, when you have absolute less than b, or absolute less than or equal to b, then you get one of these nice three-way inequalities. Okay, when you have absolute a is bigger than b, or bigger than or equal to b, then you have a set of two linear inequalities that you can't combine. Okay, so the type that you can combine is the interval, the finite interval from left to right. The types that you can combine are these disjoint intervals. So we can solve this. Minus 1/3, minus 1/3, minus 1/3. So minus 6/3, that's minus 2. And 4/3, positive 4/3, divide by 4. I can divide by 4 and leave the inequalities as 4. Sorry, what's that? You had a question. Okay, leave them as is because it's positive. So this is negative a half is less than 4x. Yeah, negative is less than x is less than 1/3. So negative a half less than x less than 1/3. So that's the set of inequalities. Here's the graphic depiction. Oops. So not including those endpoints. And if you want to write it in interval notation, negative 1/2 to 1/3. So that's how that one works. Similar example, but using the bigger than or equal to. Form bigger than or equal to 14. Okay, so 6x plus 2 bigger than or equal to 14. Actually, why don't we do this? Let's do 2 minus 6x bigger than or equal to 14. Okay, that way we'll have this, dividing by a negative later on. Okay, so 2 minus 6x bigger than or equal to 14. This means 2 minus 6x is positive and it's larger than 14. Or 2 minus 6x is negative and it's less than or equal to negative 14. All right, these inequalities, you can't combine them. Okay? So you have to write them separately and just solve them simultaneously, and that's fine. Okay, so 2 minus 6x is positive and bigger than 14. 2 minus 6x is negative and it's less than negative 14. So now we solve both of these. Well, actually it didn't really matter. That's fine. So I'll subtract 2 from each side. So minus 6x bigger than or equal to 12. And then I'll divide by negative 6. And I have to flip that inequality. Oops, negative 6. Because that's a negative number. So I have x less than or equal to 12. This one over here, so I'll subtract 2 from each side. Did I do that right? 2 minus 6x bigger than 14. Yeah. This is turning out different than I thought it was going to be. So this is 6x, minus 2, less than or equal to minus 16, divide by negative 6, and we flip the inequality like that. So this tells us that x is bigger than or equal to, so this is what, 8/3? So x is less than 12. So here's 12.
Isn't that first one negative 2?
Oh, negative 2, that's what's bugging me. X is less than negative 2. Less than or equal to negative 2. So here's negative 2. And x is going to be less than that. And here is positive 8/3. And x needs to be bigger than or equal to that. Okay, so this is minus infinity to minus 2. Union 8/3 to plus infinity.
Is the only time you flip the inequality when you divide by a negative?
Dividing or multiplying by negative, you flip the inequality. Dividing or multiplying by positive, you leave it alone.
Okay.
Right, so in this one, we divided by a negative, so we flipped. And this one here, we divided by a positive, divided by the positive 4, so the inequality stays the same. Right? They're pointing left, and they stay pointing left. And this one, right, pointing left, or pointing to the right here, divided by -6, points left. Right, so it went from right to left.
So you have to flip it when you switch from, like, on the second line, where it says 2 minus 6x is greater than or equal to 14, or 2 minus 6x is 6x is less than -14.
Oh, that's this over here.
Oh, okay.
Okay, so, well, let's just look at this one. To look at them both at the same time. When you say absolute A is bigger than B, so and B is a positive number, that means the A is positive and it's bigger than B, or the A is negative and it's less than -B. So it's these two intervals on the number line. So as inequalities, A is positive and bigger than B, or A is negative and it's less than -B. All right, so you get these two inequalities that look like that. It's when absolute value of A is less than B that you get this nice three-way thing. So this is just a standard thing to remember. Let's take another example since we're, since you asked. So one more example. So let's say that 3 minus 2 times 2x plus 4 is less than or equal to 1. So before I can eliminate the absolute value expression, what I need to do is isolate it on one side by itself. So let me subtract 3 from both sides. Now when you add and subtract on both sides of the inequality, nothing changes. It's preserved. Doesn't matter if you're adding, if you're increasing or decreasing. The inequality stays the same when you're adding or subtracting. Now I want to divide both sides by -2. All right, because the 2 that I'm dividing by is negative, right, this left-facing inequality now points to the right. All right, so here these guys go away, and I have 2x plus 4 is, oops, I wanted it to be the other one. Let me redo that, sorry. So let's say that it was less than or equal to this way. So then this is less than or equal to, and now it flips the other way. Okay? So 3 minus, 2 times 2x plus 4 is less than or equal to 1. Subtract the 3, and then divide by -2 and flip it around. So now this is 2x plus 4 bigger than +1. Right? So we have absolute A is bigger than B. So again, this means that the 2x plus 4 is positive and bigger than 1. Or the 2x plus 4 is negative and is less than -1. Right? The other way around, if I had 2x plus 4 is less than or equal to 1, then to eliminate the absolute value, it turns into this. All right, so there's two situations in where we eliminate the absolute value, when the absolute value is larger or the absolute value is smaller. Okay, and in those two cases, it's just these two things to do to eliminate the absolute value in order to solve the inequality. Okay, so it's just something you need to remember. All right. All right, so we'll subtract 4 from each side. So I got 2x bigger than or equal to -3. Divide by 2, that's positive, so x bigger than or equal to -3/2. Over here, I'll subtract 4 from each side. So 2x less than or equal to negative 5. Divide by 2. It's positive, so the inequality is preserved. So x is less than 5 halves. So you have negative 5 halves and negative 3 halves. And you want to be bigger than the negative 3 halves, less than the negative 5 halves. Right, so minus infinity to minus 5 halves. Oops. Union all right, so once you do a few examples of it, these examples that are assigned in the text, it'll just be something you remember. Okay. So go do a few examples, or better yet, one thing you can do, and they never teach you this in grade school, and I don't know why, is to redo the examples that I do. So like I gave you this example, like what you can do is take that example and do it yourself, right, without looking at my solution, and then compare what I did to what you did. If it's the same, fantastic. If not, like, where was the mistake? Maybe the mistake is on my part even, maybe. The rest in section 1.8, there's also, sometimes you have inequalities in rational functions. Let's take one example of that. These are less common, but we'll do one. In the last couple minutes here. So solve for x. So 6 over 2x minus 3. The whole thing is less than 60. Okay. So here we have a fraction inside the absolute value. Absolute value distributes over division. Right? So it's absolute value 6 over absolute value 2x minus 3. Absolute value of 6, of course, is just 6. Now I can multiply both sides by 2x minus 3 in absolute value. That's always positive. It's always positive, right? So I don't have to flip the inequality at all. So here they cancel, and I got 6 is less than 60 times absolute 2x minus 3. I could divide both sides by 60, and that's positive, so I don't have to flip it. And now I've got this. So before you can eliminate the absolute value, you need to isolate it. I mean, I could have actually did that here. No, actually, it wouldn't have worked. You have to isolate it, on its own. This linear expression within absolute value, you have to isolate it on its own, and now apply, the situation that you apply the appropriate rule to eliminate the absolute values for the situation that you have. Here we have absolute value bigger than a tenth. So this is the type where the absolute value expression is positive and it's bigger than 1/10, or the absolute value expression was negative and it's less than negative a tenth. Right.
There's a question on WebAssign.
Mm-hmm.
It's like x to the 6th power is greater than or equal to, hold on, let's see what it is. It's x to the 6 is greater than x to the 4th. How would you solve
This one?
and graph it? Yeah.
With absolute values, I'm sorry?
No, there's no absolute value.
X to the
It's on
6th.
WebAssign.
Yeah, you have to make it 0 on one side and then factor. Yeah, and then this factors some more. You with me on that? Right, then this is 0 at 0, 1, and negative 1. So you put those on the number line, and they're open dots and a part of your solution. You test the intervals, right?
Okay. Thank you.
Polynomial inequalities are always done by first setting one side to be 0. You take all the terms on one side and you push them to the other side. So finishing up this one, 2x is bigger than, so that's 30 over 10. And then divide by 2. And this one, so 30 over 10, it's 20. Oh, this is 31, sorry. So, it's time to go, so I'm sorry if I went over time here. Right, so that's the answer to that one. Okay, so have a good day, everybody. I will be in my WebEx room at 11:30. I'll send you the link with the email after class, okay? Have a good day.